My last video in my module on the trig identities, and so what we're going to do in this video is we're actually going to put together all of our trig identities to accomplish this task, and that would be using them all. Let's find any remaining trig functions of theta if we are given that cosine of theta is equal to a half and that theta terminates in the fourth quadrant. So I suppose one thing we could do is we could necessarily illustrate this here, and let's switch to a color we can see, not black. But we say, okay, so if these are our axes here, what we're given is that we have some angle, and I don't know that it necessarily looks like this, but we say it's theta and it terminates in the fourth quadrant, and this will be important as we find our things. But we're going to use the fact that the cosine of this angle is equal to a half to find the rest of the trig functions. And so when it comes to identities, I suppose it's always good to start with just easy things first. If we know cosine, so we say cosine of theta is given as to be a half, I think the first thing we should probably find is just the secant. And the reason why is because using the reciprocal identities, remember this is about the identities, we can just say that secant is a reciprocal of cosine. So we say 2 over 1 or equal to 2. So we're going to go ahead and put boxes around these. These are in our pockets. Okay, so we know these two, they are just given. I think the next one on the list we're going to go after is knowing cosine. We could actually use the Pythagorean identity or identities to find the sine. Okay, so recall that the cosine of an angle squared plus the sine of an angle squared is equal to 1. But an alternate form of this very same identity is this, that the cosine of theta, if we were to solve for that, we would get plus or minus the square root of 1 minus that sine squared of the angle. Okay, so that's the identity we're going to borrow from this time. So we say, well, if I want to know sine, then let's go down here and find cosine. Cosine, oh, sorry, we know cosine, we want to find sine. I'm sorry, we should be using then this one. To find sine, it would be plus or minus 1 minus that cosine value that we have squared. I had it backwards, apologize. So we say if we want to find sine, we say the sine of the angle theta is equal to plus or minus the square root of 1 minus the cosine squared. Well, we know the cosine of the angle to be a half, so we'd see 1 minus a half squared. So we'll go ahead and go through the steps to simplify this, but we get 1 minus, now we square the top and the bottom of this fraction, we get 1/4. And then we say finding a common denominator between 1 whole and 1/4 would be 4/4 minus 1/4. So we get this, plus or minus radical 3 over 4. And we'll go ahead and split this up into plus or minus radical 3 over radical 4, and we say, well, we know radical 4 is 2, so we get plus or minus radical 3 halves. And if you study trig, this is a number you probably know very, very well. So now the question becomes this, which one of these should we keep? And we should always ask this question, the positive or the negative one. And what it does is it goes back up over here to the fact that this terminated in the fourth quadrant. We know this, this mnemonic, all students take calculus. What this is telling us is which trig functions are positive and in which quadrants they are. Everything else in that quadrant would be negative. So for example, all of them are positive in the first quadrant. Only sine and therefore cosecant is also positive in the second quadrant. We say tangent is the only thing positive down here and cosine the only thing positive down here. Well, our angle terminated in the fourth quadrant. So we just found the sine in the fourth quadrant, and the only thing that's positive in the fourth quadrant is cosine. So that must mean that the sine is negative. So out of all of these here, we'll say that, okay, well, then we just discovered that the sine is radical 3 over 2, but it'd be negative radical 3 over 2. Okay, so we know if sine is negative radical 3 over 2, now we could use our reciprocal identity to just go find the cosecant. We'll just flip this over. So we say cosecant then would be 2 over negative radical 3, which after we rationalize this, taking the top and the bottom times radical 3, we get this, negative 2 radical 3 over just 3. And so now we have cosecant. So far we've gotten cosine, use the reciprocal identity to find secant. We use the Pythagorean identity to use cosine to find sine, and then we use the reciprocal identity to find this. Now let's find the tangent. Okay. Now recall that using the ratio identity, which said this, if you want to find the tangent of an angle, we could just take the sine of that angle and divide by the cosine of that angle. In this instance, we actually know the sine and the cosine now of this angle. So all we need to do is then plug these in. So we say, okay, well, we have sine over cosine. Let's go ahead and put in sine. We found sine was negative radical 3 halves. And we know the cosine is positive 1/2. And when you divide with fractions, instead we multiply by the reciprocal. So we take that top negative 3/2 and instead we'll multiply by 2 over 1. We can see that our 2's cancel out here and we get left with this, negative radical 3. Okay, so we say now tangent. Tangent is negative radical 3. And now that we know this, we could use the reciprocal identity again to find cotangent. We'll just flip this over. Recall this is over 1. So we'd say this is the same thing as 1 over negative radical 3, and after rationalizing this by multiplying the top and the bottom by radical 3, we get negative radical 3/3. Okay, so this is just kind of a quick demonstration of how you'd use your identities to just go from one given trig function. You could always go from any given trig function and find the other 5. You just have to use your identities.